Multivariable systems, linear systems to be specific. So we're looking at x, y, and z formulas essentially. You're going to have three variables going on. Now typically these will be what they call square functions, where you also have three equations. When you have three variables, you should have three equations. So the idea, these two are equivalent systems. Okay, so you have these combinations with x, y, and z in every line. The idea today, we're going to take this and change it so it looks like this. This is what's called row echelon form. Okay, sometimes it's also called stair-step pattern, because all of them have a leading coefficient of 1, and you start with the x in the top, y in the middle, z on the bottom. So it steps down. Okay? Now, the nice thing about once you have it in this form, this thing to figure out x, y, and z is a bit of a challenge. You can technically do it with weird substitution methods and elimination, but honestly, it would take the entire, well, about 2/3 of the chalkboard to do this one problem using standard elimination and substitution.
You mean whiteboard?
What?
You mean whiteboard, not chalkboard?
Whiteboard, chalkboard, whatever. Anyway, I still miss my chalkboards, honestly. I like the chalkboards better. But, equivalent system, so the idea, once I have it down to this, what can I do to find x, y, and z? Yeah, just literally plug in those values to the previous equations. Okay, so if they're being really nice to you and giving you the original problem in this row echelon form, go ahead and find x, y, and z for me.
Z equals 3.
1/3 of the way done.
Y is equal to -3.
Y would be -3 and
Hold on. Math. X is equal to 2.
x equal to 2. Now how would I write that?
2, 3, 3.
2 comma what?
2, -3, 3.
Anybody know what that's called? When you have two of them, it's an ordered what? This is an ordered triple. This is literally describing a point in 3 space. Okay? Now, that's not bad when it already looks like that. To get it there, we're going to use something called Gaussian elimination. Now, what Gaussian elimination allows you to do 3 things to anything in that system of equations. You can interchange or swap any 2 equations. You can multiply one equation by some number that's not 0. And you can add a multiple of one of the equations to a second equation and then replace that second equation. Between those operations, we'll be able to take something that looks like this and make it look like those stair steps, that row echelon form. Okay, now this process does take a little bit of work and a little bit of time, so let's work through it. Now, I do shortcut the book a little bit on these. First off, I want it to be that row echelon form, so I need the top row to have a leading coefficient of 1. Does it? Yeah, so I don't need to do anything with the top row, so I'm going to skip that step. The next row, I'm actually going to do the next part at the same time. Because what I want to do is I want to take this top row, since it has a leading coefficient of 1, I can use this, the fact that it has 1x at the front, to eliminate the x's in both of these next 2 rows. What I'm going to do is I'm going to take row 1, I'm going to multiply it times the opposite of this. Since that's 1x, I can just multiply by -2 times row 1, because that'll give me what? For the first part of it. -2x. And then if I add that to row 2, what's going to happen to the x? It'll go away. But then I still need to do that with everything else in row 1 and add it to row 2. So the top row remains the same. I'm not changing anything there. But I'm using that original row as a tool to modify the second row. So x is going to be gone. For y, I'm going to take -2 times the y up here, and then add that to -1y. So that's -2y plus -1y is what? -3y. Then I'm going to do the same thing with z. -2 times z is -2z plus z minus z. -2 times 6 is? -12 plus 3 is? -9. Okay? Now, the book would have you then just copy down this row the way it is, and then do it again, but this time use row 1 to eliminate the x in row 3. I'm just going to do them both at the same time. It makes better sense to me to eliminate, okay, this step we eliminate all the x's that we don't need. So I'm going to do this right now. What would I need to do, how would I need to use row 1 to get rid of the x in row 3?
-3.
Negative 3 times row 1 added to row 3. Does that make sense? Okay. So then x is gone. What do I get on the coefficient for y? Yeah, negative 3y plus 1y is negative 2y. What about on the z? Yeah, that'll be negative 3z plus negative z is going to be negative 4z. And for the constant? Negative 16. Negative 3 times 6 gives you negative 18 plus 2, negative 16. Okay, now from this point, I already have this top row done. I want to take the second row, or whatever's in the middle there, and I want it to have a leading coefficient of 1. Now, what could I do to the current middle row to make it a leading coefficient of 1? Divide by negative 3. The only issue with that, and I can do that, that will work, but what would that give me for the z coefficient? 1/3. Okay, I don't want to deal with fractions if I don't have to. Now the nice thing about the third row, what if I got y by itself in the third row? Would I have any kind of weird fractions or anything to deal with? No. So that's the one I'm actually going to do, because then after that, I'm allowed to do what with two rows? Oh, easier than that. You can actually just flip their positions. So what I'm going to do first is take this row, and we'll do what to get the y by itself? Except for we're not allowed to divide technically. Times by negative half. Okay? Because in reality, division and subtraction both do not exist. Okay? Becomes a little bit important later. We're going to do more stuff with these kind of things later on where you cannot divide whatsoever. It actually is an operation that doesn't work. Okay? So here we're going to phrase everything in those terms, multiplication and addition. You just need to make sure you multiply by the reciprocal. So when I do that, top row I'm going to remain the same. Current row 2, I'm going to remain the same. So negative 3y minus the z is equal to negative 9. And the bottom row is going to turn into what? Equals 8. Now I'm going to swap those two rows. Okay? So I'm going to make this one go up here, this one go down here. I'm actually going to carry this down. Ideally, you do this on a longer sheet of paper where you could do this all out in one long row. But if I bring those down here, another way you can write this is I'm going to send row 3 to row 2. And I'm going to send row 2 to row 3. So you'll see it written that way sometimes too. Row 1 I'm just going to leave the same. So x plus y plus z is equal to 6. Down here, what was row 3, the y plus 2z is equal to 8. And negative 3y minus z is equal to negative 9. Okay, you can just swap two rows. It's not going to change the x, y, and z values. Now finally, to get it down to row echelon form, what would I need to do? What? I just didn't follow what you were saying, honestly.
Change the second one, times it all by 3, and then add the second and third rows together.
Okay, now just be careful in the way you're saying that, because the thing is, are you actually changing row 2?
You're just making it
Well, but I'm not going to, over here though, am I going to write a different row 2? I'm not going to change it at all, because you notice we never actually changed row 1. We used it as a tool to modify the other one. but I'm not going to change, and that's just a part of the language. I don't want people to get lost on it. These two rows are done. I don't need to do anything else. These both have a leading coefficient of 1, and they're in that stair step, right? The bottom row, I need to eliminate what? The y. So I'm going to use row 2 as a tool to do that. I'm going to do it the way you said it, but I'm not actually changing row 2. I'm just using the properties of row 2, taking those times 3, and then adding them to row 3. Because essentially what that means is I'm adding the same number to both sides of the equation on row 3. I'm just using the fact that this row 2 has to be following the same XYZ pattern as what the row 3 equation is. So I can do that. The y is gone. What do I get for a coefficient on the z? So you're going to take the 3 here times the 2, giving me minus the 1z, 5. That's going to equal over here, 3 times 8 minus 9. 3 times 8 is? 24 minus 9 is? 15. So then, if I actually want to get this all the way down to row echelon form, what do I need to do last in row 3? Not divide by 5. Multiply by 1/5.
Isn't that like the same thing though? Like, I don't get what you're saying, like you can't divide.
For the notation wise, we want to stick to multiplication because it's going to help you later on. Okay? You use that habit now.
Okay.
Really, dividing by 5, it does the exact same thing. This is just kind of getting used to seeing this notation, so when you refer back to it in the book, it's like, okay, why are they doing that? Well, they're dividing by 5, they just aren't writing it that way. Okay? Yeah. To keep it organized, honestly, you will lose track of pieces if you do not have some organizational method. This is the shortest way to write what you're doing. Okay? So this is basically the most efficient way to do it while not losing track. Okay? So x plus y plus z is equal to 6 is still there. And you will have problems that say use row echelon form or use Gaussian elimination. You do need to go through this process. Okay? You have y plus 2z is equal to 8. And lastly, I have z is equal to what?
5.
3.
I want it equal to 5.
Oh, sorry. No luck. So, my ordered triple then. What do you have last? 3. Plug 3 back in up here. What are you going to get for y? 2. And for the first one? 1. So, you use 1, 2, 3. So that's a point in 3 space that describes where all 3 of these equations coincide. Yes?
Do they have 3-dimensional graphing calculators?
Yes. 89 titanium will do it a little bit. I think those run about 175 or so ballpark. The Voyager 200 will do it, and those are about $250. I have not seen a phone app like either Android or iOS yet that will actually do it reasonably. Okay, there are computer programs, quite a few of them, Mathematica, Maple. Can't think of what the other one is, the other big one, but those will do 3D graphs as well. And if you're a math major, you'll have to buy at least one of them. Students get a decent discount though, but for this one, you guys walk me through it. What would I need to do first? Interchange, because I don't have a leading coefficient of 1. First thing I would do is swap these 2 rows. Bottom row remains the same. Then what? Okay, so I'm going to do that for both second and third. What would I have to multiply the first equation by to get rid of it in the second? Negative 3 R1 plus R2. And what would I do in the third equation? Okay, so top equation remains the same. Second equation, x is gone. What are you going to get for y? Negative what? Yep, negative 3 plus negative 2 is negative 5y. Plus 10z is equal to what? Eight? Negative 8. Okay. So then, the bottom row. Negative 5y. Plus 10z is equal to? Say again? Anybody else? 2? Okay. Just making sure. Then what? What would I need to do next? Yeah, get rid of the coefficient. Now, I also, though, see, you can kind of skip steps around a little bit here. I see negative 5y and negative 5y. I'm going to take advantage of that because before I bother reducing this down to y, what can I do with row 2 the way it is to get rid of the y in row 3? Just subtract them. Just take negative, well, sort of. You do negative row 2, add to row 3. And that'll replace that row 3. So when I do that, I'm just going to go down here with it. So I still have x plus y minus 2z is equal to 3. Second row, I'm going to wait a second. On the bottom, what happens to the negative 5y? Goes away. So then what coefficient do I have on the z? So I have 0 plus 0? What do I have on the other side? Yeah, you have negative of negative 8, so that's positive 8, plus 2 is 10. What's that mean? When you have 0 equals 10 with no variables.
Those 2 lines of parallel.
They don't intersect. So there's no solution to this one. Now the y, I could also, if I want to take this and divide by, or multiply by negative 1/5 to row 2, that would just give you the y minus 2z is equal to 8/5. But as soon as you have the 0 is not equal to 10, it means no solution. And you can have this just like before. You can have one solution, you can have no solutions, or you can have infinitely many. The caveat here is that the infinitely many is a little bit strange because this is being a little bit deceptive. This says a system of linear equations. They are linear equations in their properties, but in 3 space they do not make lines. In 3 space, x plus y plus z equals a number makes a plane. Okay, it's not actually talking about a series of lines here and where they intersect. This is talking about planes and where they intersect. So if you have one solution, you can almost think about it as the corner of the room. Planes in this room are the floor, the front wall, and the side wall. Well, where would they intersect? Yeah, the bottom corner. Okay, that's your one point of intersection. That's like the 1, 2, 3 on the first problem. The last one was no solution. Notice we have 2 different versions of no solution here. We have either you can have all 3 that are parallel to each other, but don't go through the same points, or you can have where they kind of have intersections going on, but they don't have any combined ones. So if you think about the floor, the ceiling, and the front wall here, those don't have any points of intersection that are common to all 3. The wall and the ceiling meet in a line, the floor and the wall meet in a line, but nowhere do all 3 of them meet. The infinitely many, that's where you get a little strange. Infinitely many, you can actually have one solution or one plane out of all those. So if you think about the tile on the floor, the glue underneath it, and the concrete underneath that, it's not quite a plane, but think of that as one plane. You can have 3 different equations that represent that same plane. Okay, that's an infinitely many solutions. That's actually a fairly easy one. Because the same thing happens as what happens when you do elimination on two lines that intersect, or that coincide. As soon as you do the first step, everything goes away. You just get 0 equals 0 for the second equation and for the third equation. So the only thing that's true is the first equation. And that's your plane. Now, this is the one that you have to get a little bit creative with. When I have three planes all intersect, well, what do they actually intersect as here? A line. So I need to be able to describe that line. Okay? Work-wise, they're actually a little bit less work than the 1, 2, 3 problems. Okay? Conceptually, they're a little bit stranger. So those images make sense? Everybody got a decent mental picture on this stuff? It is weird, but we're going to keep it fairly simple, just the planes right now. We're not going to do lines in 3 space yet. Okay. So, if I want to solve this system, now flat out, this one's going to end up as one of those infinitely many ones. Well, what would I do first?
Change the second equation to get rid of that.
Yep. So I'm going to change the second and I'm going to change the third, just to save writing. So how would I do that to change the second one?
Multiply the first one.
Yep, multiply the first one times 2 and add it to 2. Okay. So finish off writing this. What do I end up getting for the second equation then? X is gone. What do I get for Y? Negative what? Yeah, you have negative 4 plus 3, so that's negative Y. For the Z?
Negative 13.
Careful, it's negative 2 times negative 7. So that's positive 14 plus 1 is 15Z. Is equal to? 9. No, not 9. 13. You have negative 2 times negative 4. It's positive 8. Don't lose the negative signs. That's what's going to catch you on this stuff. So I have 8 plus 5, so 13. Now in the next equation, what would I do to get rid of the x? Yep, negative 3. Row 1 plus row 3. So x is gone. What do you have on y? Negative or positive? Positive. On the z? Negative 3 times negative 7 is 21. Negative 36, so in other words, take away 21 from 36, you get negative 15. Then for the constant, negative 13. So, the second equation is actually already in that format. So if I use the second equation to eliminate the y in this, or the third equation I should say, to eliminate the y in the second equation, what would I actually multiply the third equation by? Or would I? No, I can literally just add that. Row 3 plus row 2. So I still have the x plus 2y minus 7z equal to negative 4. This one, the y is gone. What happens to the 15z? And the 13s? 0 as well. So on the bottom, I still have y minus 15z is equal to negative 13. I have 0 equals 0 there, so then I'm going to swap the position of the last two just to get into that row echelon so I can see things well. So I still have the y minus the 15z is equal to negative 13, and 0 equals 0. Now, because that's a true statement, but all your variables are gone, that means you're going to have infinitely many solutions. But I still have this second equation. That tells me it's not going to be three planes that all coincide with each other. It's going to be ones that come together on a line. Three different planes. So what I need to do is determine what z is. Because 0 equals 0 here, z has no limitations on it. So what could z be? Any number. So z is literally any number. So we typically just use a for that. So if z equals a, then I'm going to define the other ones based on the fact that z can be anything. So then, what would I do to find y then? If z is determined to be a, how can you find y?
I have 15 variable sides.
Yeah, you're literally just going to plug in a in place of z. So if I add 15a, I have y is equal to 15a minus 13. So there's my y value. How would I get the x value?
Plug in y and z.
Yeah, plug them both into this equation. So x is going to be equal to 2 times, x plus 2 times, getting ahead of myself, 15a minus 13, minus 7 times what was z, is equal to negative 4. So, distribute the 2. What do I get for the coefficient on a? 23a. What do I have on the other side? If I move over the 26? 22. So I'm going to add 26 to both sides. Give me 22. So x is going to be equal to what?
-23a
Plus 22. So then my answer, I would write it, again, still as an ordered triple. So I would literally just put the x first, then the y, then the z. But then I also said a could be what? What does the a stand in for? Any number, and there it's actually very general, all the way down to all the reals. So a is an element of any real or of the reals. That's what your answer looks like.
So you only did it that way, like,
Z would only be equal to any numbers if you have the second equation.
Yeah, if you still have the second equation, exactly.
So if you don't have the second equation, then it's
The only thing left, because basically if the second equation is just 0, 0 and the third equation are both 0, 0, okay, then all you have left is the original. So that's the equation of your plane, because they all are literally the same plane.
Okay.
Questions so far? Okay. Next up, the non-square systems. That was the square systems. We got the non-square systems. In other words, you do not have the same number of equations as you do number of variables. In reality, these problems are easier. Because what ends up happening, essentially I have 2 planes instead of 3. Well, are 2 planes ever going to intersect in a single point?
No.
No, they will always intersect. If they do, how? In a line. It's like having the floor and the wall. They only ever intersect in that one line, since I'm not adding a third plane to it. So you know you're immediately, as long as stuff isn't going to cancel out on you. In other words, as long as you can't multiply the first equation by one number to generate the second equation, then immediately you know you're going to have something be a. Well, look at this circumstance. If I move things around a little bit, I have 4x minus z equals 0. Well, what would that look like if I cleaned it up a little bit to be a little nicer? What can you do with it? The second equation. Yeah, just move the z to the other side. This is 4x equals z, right? That's the same thing. Well, I know this thing because I can't think of any number I can multiply this by that would generate this, because obviously the y would still be there if it did. Then I can jump straight to the anything part of this. Which letter would you want to make anything? Because it's actually arbitrary. You can make whatever letter you want be that, and then base everything else on it. On the other kinds of problems, it's easiest to make z equal that at the start, because that's the thing you're going to be reduced down to. Here, what's going to be the easiest thing to make a? X. Because z is based on what you're doing to x, right? So if I make x equal to a, then what's z equal to? 4a. Then how would I find y? Plug both those in. X is a minus y plus 4 times 4a for z is equal to 3. So I get negative y plus what? 16a plus another a, 17a. So what's y equal to?
17 minus
Yeah, move the y over and the 3 over. Y is equal to 17a minus 3. So what's your order triple?
3.
And 4a. And again, a has to be a real number. So those non-square ones actually aren't bad. Because either immediately stuff's going to cancel off and you're done, they're the same plane, or they're going to intersect in one line. Okay? Now, some of the word problems.
What, you can use word problems out of this?
Oh God.
Yes, you can. Now, what's going to happen here is you're actually going to do things. This allows you to take values, and this doesn't take long. We'll just kind of set it up. What you're going to do is take the values that you know into equations where you don't necessarily know everything about it. So the idea is this: I have data collected. So I have these 3 answers for the amount of time passed and the position of a falling object.
Perfect.
Okay? So I have the equation for the relative position of an object at any given time. So I'm given t and s. All I'm going to do is plug in t and s. So for 104 feet, this is going to be equal to 1/2 times a 1 squared. Well, it's just 1/2 a. Plus 1 times v sub 0, the initial velocity, is just v sub 0, and s sub 0. Well, notice the structure looks different, but this is literally just your x, for lack of a better term. And you're going to get 3 of these equations. So then do the same thing with the next one. I'm going to have 76 is equal to what? 2a. So you take 2 squared and then half of that. Plus 2v sub 0 plus s sub 0. Then you do the same thing for the next one. 16 feet off the ground at 3 seconds. 3 squared and a half is 9 halves. Plus 3v0 plus s sub 0. So then it's the same as the problems we just did. So the word problems are literally just setting up those. So you'll see ones like this that are kind of contrived. You'll also see ones where they give you 3 points and make the equation. It's the exact same concept. You're replacing the x's and the y's. Your variables end up being the a, b, c. This one's really easy because of the 0, 0 here. If I plug in 0, 0, what am I going to get? C equals what? 0. Because the a will be gone, the b will be gone, the y will be gone. It's just c equals 0. Okay. Not going to solve that all the way out. Questions on any of it? Okay. Spend some time with it.